This presentation is on the or to solve two of the most important questions in case of designing hydrotic structure for a specific catchment. First question is how to find the exceedance probability of an extreme event. Second question that I want to answer in this presentation is how to analyze the relationship between the magnitude of rainfall and its exceedance probability. So today we will discuss about these two questions. So the first question can be answered with the help of this formula. Probability of a precipitation, suppose it has a magnitude of x centimeter and has a duration of y hour. We want to know what is its probability of that event to occur odd times in the next n years, next n number of years. That formula will be PRM, NCR, n combinatorial R, probability of that event to the power R, then multiplied by Q to the power n minus R. This Q is the probability of that event not occurring in the n successive years. Or you can say that 1 minus probability P is Q. That means it is the probability of that event not occurring odd times in the next n number of years. Okay. So let us take a simple problem and solve it. So suppose you have been given that the return period of a certain event t is 20 years, and what is the probability of that event to happen again for one time in the next 20 years. Have you got my question? The question is that a precipitation event, suppose take for example 20 centimeter rainfall, which has occurred for 3-hour duration. What is the, and it have a return period of t is equal to 20 years. What is the probability of this event or some event which has more than 20 centimeter rainfall to occur again in the next 20 number of years for only one times? What is the probability? Okay, so how we have to find it? Here you see t is equal to 20 years. As you know, 1 by t, inverse to the return period, is your probability. So you find what is 1 by t. Then your next is you apply this formula. This is n factorial. This n is the next n number of years. Here n is 20. What is R? I have said what is its probability to happen again in the next 20 years for one time only. So R is the number of times. So it will be 1. So R is 1, N is 20. So you apply the formula, this formula. R is 1, N is 20. So it is coming as 20 C1 P1. Now Q is the, what is its occurrence? What is the probability that this event is not occurring for one time in the next 20 years? What is the probability of this event not occurring for one time in the next 20 years? So it is P to the power 1, and then Q is that not occurrence probability. So Q to the power n minus 1, n minus R. So n is your 20, R is your 1. Now 20C1, you see, this is nothing but 20 factorial, this one, this part. 20 factorial divided by 20 minus 1 factorial, then R, that is 1 factorial, correct? This one is this. And what is your P to the power 1? I have already said P is equals to 1 by T. Your return period is already given. This is 20 years. So your P to the power 1 will be 1 by 20. Correct? And this Q to the power 20 minus 1 will be nothing but 1 minus 1 by 20. Now you solve this, and then you will find your desired value or desired variable. Correct? So as you can see that it is very relatively easy to find the probability of a precipitation event of 20 centimeter magnitude, duration 3 hours, to happen again in the next 20 years for one time. Okay, so your R will be, R is 1, your R will be given, your N will be given, X and Y doesn't matter, it doesn't come into calculation, and of course the return period of that event will be given in the problem. So what you will do, your first step will be to find the inverse of return period, that is P, probability, that means this term, and 1 minus 1 by T or 1 minus P is actually this term Q. After you have found out this one, this part of this formula, then you find out these factorials, n factorial, this n will be the next successive years. In this case it is 20 years. So n will be 20 for this case. R will be 1 because I want to know how many times, I want to know the occurrence of that rainfall for one time only in the next 20 years. So R will be 1. Then R factorial is there, R will be 1. So you can easily get this part also. Now multiply both this part A and B and you will get B. So this is the way you get the probability of this event, which can occur for one time in the next 20 years. Now I will try to answer the next question, second question, that is the relationship between the probability of rainfall, but to be more precise, occurrence probability of the rainfall with its magnitude. for a certain duration of time. Now this is also known as intensity or frequency analysis of rainfall. Frequency analysis of rainfall. So it is not intensity, it is frequency analysis of rainfall. So let us take an example problem and try to find the answer to the second question. Here what will happen is you will be given the magnitude of rainfall for the last 10 years or 20 years or 5 years or 7 years like this. So for example, if 5 years rainfall is given, take 2022, it is 120 centimeter rainfall. Suppose this is the peak rainfall, correct, of the year 2022. In 2021 it was 90, 20 it was 150, suppose 19 it was 250, 18 it was 135, suppose. So this is all example, this is all random numbers, this is not real rainfall data. So now if you are asked to find the frequency analysis of rainfall for the last 5 years from this given data, what you will do? Here you will apply a plotting position formula. What is that plotting position formula? Here I will apply Weibull's formula. But there are many more methods available for calculating the plotting position of a rainfall from the frequency analysis curve, or the curve of, or the graph showing the occurrence probability in y-axis and the magnitude of that rainfall in the x-axis. So the method for Weibull formula is, first arrange this peak rainfall in descending order of their magnitude. So the rainfall which is highest among these 5 rainfalls given to you will have the best rank. Suppose this is the rank 1. This is known as rank or order. So followed by, I have said, descending order of rainfall, order of magnitude. So 150 will be second position, get the second position. 135 will get the third position. 120 will get the fourth position, and 90 will get the fifth position. Remember, descending order of magnitude. So the highest magnitude will have the best rank, lowest magnitude will have the least rank or the worst rank. This 1, 2, 3, these things are known as rank or also order of rainfall. So the formula states, or the Weibull formula says, that the probability of rainfall can be given by M, which is the order of the rainfall for which I am calculating the probability, divided by N plus 1. N is the total number of rainfall available in that data set. In our case it is 5, right, plus 1. So suppose I want to find the plotting position or probability of the rainfall having the magnitude 120 in this data set, that is the peak rainfall of 2022. So what I find, as per the descending order of magnitude, it has a fourth position. It has the fourth position. So M will be 4. N, here total number of data set given to you is how many? 5. 5. N will be 5. So this term will come as 4 by 6. So it is coming at around 4 by 6. That means it is coming 0.667. Correct? So let us confirm it again in the calculator. So although it is very easy, but you must be, yes, 0.666, so 0.67. So you can write this as 0.67. 0.67 is the probability of this rainfall. Okay. Now you have to calculate the probability of the next rainfall, or this one, this 90 centimeter, which is the peak rainfall of 2021 of a certain catchment. So the order is 5. So M is 5 here. Now N is 5, as we have the same number of rainfall given to us. So it is 5 by 6. So 5 by 6, what is the answer? You have yes, it is 0.83. So the probability is 0.83. Similarly, this rainfall will have a probability of, it has an order of 2, that is M is 2. So 2 by 6. So the order will be 2 divided by 6. So it is coming as 0.33. Now the highest of the peak rainfalls of the last 5 years. Best position, order 1. So 1 by 6. As usual, the highest rainfall is the extreme event, rarely happens. So it has the lowest probability. So 0.16. So it is 166. So I can say it's 0.17. Now lastly, the fifth data set, which have the order of 3, that is the rank 3 by 6. So I think no need to have calculator, 0.5. Correct? So this is your 0.5. Now you can see that we have calculated all the probability of the rainfall given in the data series. Now, if I arrange these probabilities with the magnitude of that rainfall in the descending order of magnitude, you will see we'll get a curve something like, suppose this would be the highest rainfall, 250. This will be the next highest rainfall, 150. This will be the third highest rainfall, 135. This will be your 120. Now you see this highest rainfall has the lowest probability. Naturally, this is the extreme event. So this curve will be like that. Okay, so this curve, now this, as you can certainly understand that this y is nothing but the probability of this y is nothing but the probability Nothing but the probability of these rainfalls. So this is the curve of which is helpful for the frequency analysis of rainfall. Frequency analysis of rainfall. And for designing hydraulic structure, these curves are used. It's a very simple process. We have used here Weibill's formula, but there are many available formula here. So you can use any of them, but the most simplest formula is Weibill's formula. And why it is known as plotting position? Because by applying this Weibill's formula, we are trying to find the position of that rainfall in this curve, in this plot. That is why it is plotting position. So you see that this is pretty easy. You will be given a set of rainfall for the last 10 years, 5 years, 6 years, whatever it may be. You will be given that rainfall. First step will be to arrange them in the descending order of magnitude. And when you arrange them, then the highest rainfall will have the best rain, and the lowest rainfall will have the least rain. After that, just use this formula m by n plus 1, where m is the rank, or we also say it as order of the rainfall. So m is your rank, n plus 1, n is the total number of data given to you. For our case, it was 5. For your case, it may be different. Plus 1. Now you use this formula to calculate the probability of each of the event given in your data set or data series. Then in the y-axis you put the probability, in the x-axis you put the magnitudes, and you show the curve. That is all you have to do to find the what I can say, to analyze the frequency of rainfall for a certain catchment. So in this presentation we learned about two uh, very important terms. One is probability, another one is plotting position of the rainfall. Now in case of probability, what we have found is that what is the occurrence probability of a certain event having a certain hour of duration to happen again in the next n successive years for a number of times. And in that case, we have used the simple formula NCR, and that is the n combinatorial R multiplied by the probability of that rainfall, which can be calculated from the return period of that rainfall, and that is also multiplied with the not occurrence probability, or Q. That means what is the probability that that event will not occur in that same n number of successive years and for a number of times. So that was the formula for calculating probability of that rainfall or of that event happening again for a certain number of times. So this is important for designing the hydraulic structures, because if the probability is very low, then it is better to design the structure with respect to an event which have a little bit higher probability. That way you will save uh, the cost or reduce the cost, and you can be assured that the chance of disaster or chance of risk will be minimal. The next is for in-depth analysis of that same concept. We try to find the relationship between the probability of the event with respect to the event itself, magnitude of that event. For that we use Weibull formula, and I have already explained what you have to do. You will be given number of data points, or the number of peak rainfalls for the certain number of years. You arrange them in the descending order of magnitude and assign them orders or assign them rank, where the highest rainfall will get the best rank, lowest rainfall will get the least rank. And then what you will do, you apply the Weibull's formula, P is equal to m by n plus 1. Here m is the order of rainfall or rank of the rainfall, divided by n. N is the total number of data points available to you, so plus 1. So here the order of rainfall means the rainfall for which you are finding the probability. So in this way you find the plotting position, then you plot the data, plot the probability with respect to its magnitude, and you will find a curve similar to this. So this is all you have to do, and with this I finish this presentation.